Hello students. In the previous chapter on the polynomials, we explored the algebraic expressions, their zeros graph, and the relationship between the coefficient and the roots. We saw how equation can represent curves and how algebra connects beautifully with the geometry. And now we are going to take the next step, which is a step forward. And instead of working with this single variable like x, we will now introduce two variables, x and y. So this allows us to represent the relationship between the two quantities, which is much closer to the real life situations. So welcome to the chapter 3, which is the pair of linear equations in two variables. So in this chapter, we will learn how two equations can work together, their graph represents straight line, and how their intersection give us a solution. We will also explore different methods like substitution, elimination, and the graphical approach to solve these equations. And this chapter is not just about solving equations, it is about understanding the relationship and interpreting them visually and algebraically. So let's begin this journey of connecting algebra with real life application. Okay, so the key topics that we're going to cover today as a part of this chapter is we are going to have a quick understanding on the concept of linear equation in two variables. We'll understand how the graphical representation of these linear equations can be done and how we can solve a particular say, pair of linear equation with the help of a graph. We'll understand the algebraic method of the solving, which includes the two basic methods, which is the substitution method and the elimination method. And then we'll cover all the NCERT exercise questions. And then we'll have a quick snapshot slide, which gives us a quick overview about this chapter and some of the learning mechanism and learning tricks. And then we will wrap up this chapter and mention which chapter we are going to come next. So let's move with the introduction slide. Okay, now we understand the concept of linear equation in two variables. So first we'll understand the concept of the linear equation in two variable, that how it is represented and what is the standard form of a linear equation in a two variable. So standard form is very important because that helps us to understand that in which form a question will come and in which form we have to evaluate the problem so that we can able to understand and the problem and convert that problem into standard form before solving it. So a common form or the most standard form of a variable is in two variable is ax plus by plus c is equal to 0. This is the standard form. So which means that if a are given equation, let's say ax plus by is equal to c, then what we have to do, we have to first translate that equation into ax plus by plus c is equal to 0 form to get the value of a, b, and c. And we are going to touch base that how this is of relevance when we move to the actually solving the questions, and then we'll understand the concept in more detail. So the variables are x and y. A, B, C are the constants, and A, B, C are nothing but A, B, C can be associated with x, y, and constant, where A is largely associated with x variable, where B is associated with y variable, and C is constant. So when we talk about the linear, the term linear means the highest power for a variable is 1. And we have discussed this during our discussion when we were discussing the polynomial, wherein we discussed that in an equation with the degree is 1, then it is a linear. If the degree is 2, it is a quadratic. Highest degree is 2, it is a quadratic. And if the highest degree is 3, then it's a cubical expression. And we also understood that a graph of the linear equation is always a straight line. So example 2x plus 3y minus 6 is equal to 0, x minus y is equal to 4. Now look at this equation, x minus y is equal to 4 and 3x plus 2y is equal to 5. This is a variable basic equation in the two variable, but it is not the standard form. So standard form is x minus y minus 4 is equal to 0, and likewise 3x plus 2y minus 5 is equal to 0. That is the standard form. Though equation is definitely an equation in two variable, but it is not in the standard form. And how we can solve a particular linear equation, a solution of the pair of the variable values of x and y can satisfy the equation. So typically what we have to use, we can put some values for a x and derive the value for the y, and likewise we can get the combination of the value of the x and the y. There are infinitely many solutions for a particular set of the equation. Graphical meaning is that each solution represents a point on the graph. So when we draw the particular graph, particular equation on a graph, then definitely it has both the line will intersect and then it has a unique solution. When plotted, all the solutions lie on the straight line. But if we individually try to plot a particular linear equation, then it will have the infinitely many solution, because for every value of the x, there would be the corresponding value of the y, and that can be represented infinitely many solution when, but definitely the plotting will happen on the straight line. The important observation is that linear equation is an infinite solution. Each solution has a point on the line, and all point together form a straight line. This is a typically method how we can represent a particular linear equation in two variable in a graphical form. So with this, we actually understood the concept of the linear equation in two variable, that what is the standard form ax plus by plus c is equal to 0. Now we'll move to the next slide and look some of the other concept of linear equation. Okay. Now what we're going to cover today, cover in this chapter further, is graphical presentation. Having understood the concept of the linear equation in two variable, and understanding the concept that how it can be represented in a graph, what we are now going to show is we are going to take a look at a particular set of the equation and try to solve and find the solution of those set of the variable equation in two variable with the help of a graphical method. So let's start that. So a linear equation in two variable can be represented graphically on a coordinate plane. A pair of the linear equation which has no solution is called an inconsistent pair. Very, very important. So which means that when we are given a two set of variable equation, and when try to solve that particular equation graphically, and there is no intersection point, then definitely that particular pair of the equation is inconsistent pair or the linear equation. A pair of the linear equation in two variable which has a solution is called a consistent. So pair of the linear equation which has solution is a consistent pair, while a pair of the equation which do not have a consistent solution, which does not have a solution, is an inconsistent pair. A pair of the linear equation which are equivalent has infinitely many distinct common solutions. Such a pair is called the dependent pair of the linear equation. So we have a situation wherein pair is consistent, but it has infinitely many solutions. And we'll learn about all this situation in the below slides, in the below format, that what a particular solution is unique, and then when how it can be presented on the graph, and then what is the relationship between the unique solution and the intersection. So what we have done, we have three our options or three possible outcomes that are there. So we are saying that lines may intersect in a single point. So which means that in this case, the pair of the equation has a unique solution. So whenever a pair of the equation has a unique solution, they are treated as a consistent pair of an equation. And in this, what is the outcome? What is the method of ensuring that, and how we can demonstrate that a particular set of the equation has a unique solution, is that if the a1 upon a2 is not equal to the b1 by b2, which means that intersecting lines are there and will have only one solution. And before understanding the concept of a1, a2, b1, b2, the equation has to be in standard form. This is the most important priority. So equation has to in the standard form before we can calculate the value of a1, a2 or anything else. So first of the equation has to be in the standard form. This is the prior condition before we can calculate any kind of a1, a2. So when we are saying that a1 and a2, a1 by a2 is not equal to b1 by b2, which means that this is a situation when the pair of the linear equation in two variable will be having single solution, and when we represent that graphically, it would be an intersecting line. Second option can be the line may be parallel. In this case, equation have no solution. So which means that this is considered as inconsistent pair of the equation. And how we can demonstrate that? If a1 by a2 is equal to b1 by b2, but it is not equal to the c1 by c2. So this is a situation when the two pair of the lines when presented graphically will not intersect each other, and they will be parallel lines, it will not have any solution, and it will be treated as a inconsistent pair of equation. And the third option is that line may be coincident. So which means that in this case equation have infinitely many solution, and which is normally treated as dependent, consistent, and the pair of the equation. So when a1 by a2 is equal to b1 by b2 is equal to c1 by c2, then these are treated as the coincident lines and will have infinitely many solution. Coincident line means a line on a line, and it will have a infinitely many solutions. So which means that though those two equations will be represented in the same line, and it will have infinitely many solution, and it is not going to have a single solution. So we can demonstrate it with the help of a example here. So we are saying that we have to verify whether x plus 3y plus 6 upon 2x minus 3y by 12 is consistent, and if yes, then we have to solve it graphically. So even before proceeding to the first equation, what we have to do, we have to convert this particular equation into the standard form by x plus 3y minus 6 is equal to 0 and 2x minus 3y minus 12 is equal to 0. Then we'll compare the A1, A1, A2 and B1, B2 and C1, C2. So A1 is 1, B1 is 3, C1 is 6 because when we convert this into AX plus BY minus AX plus BY plus C is equal to 0, then C will become minus 6 because this is a standard equation. Likewise, A1, A2 is 2, B2 is minus 3 and C2 is minus 12. So this is most important. So before actually solving the equation, we have to first convert the equation into standard form, then we could able to solve it. And when we try to compare A1 by A2 with B1 by B2, we say that A1 is 1 and A2 is 2, B1 is 1 and B2 is 2. So which means that 1 by 2 is not equal to 1, which means that in this equation, we have one solution. So how we can then solve it further? We have to put one value for some value for x to get the value of the y, and then some value for so at least two value at each equation that will help us to draw the graph. So typically what we can use one value as 0 for the x to derive the value for the y, and then we can use the one value 0 for the y to derive the value for the x. So this is a typical method through which we could able to create a set of the variables, and then we can plot these variables on the graph. So if we look at the first equation, so 0 by 2, 0 and 2 and the 6 and 0. So 0 and 2 and 6 and 0, this is for the first equation. X plus 3y is equal to 6. This is the graph for the first equation. And likewise for y, for the second equation, which is 2x minus 3y is equal to 12, these are the variables 0, these are the values 0 minus 4 and 3 minus 2. When we plot them graphically, we arrive at a single solution. And that single solution is 6, 0. So which means that this particular set of the pair of the linear equation in two variable has solution 6 and the 0, wherein x is equal to 6 and y is equal to 0. And this is the solution for this particular problem. So this is how we represent a particular solution through graph. But the most important point and most relevant point is that whenever we are given a question, we have to ensure that that particular equation needs to be converted into the standard form before actually doing it any further action on that, so that we could able to figure out whether the solution is consistent, and if consistent, whether it is a unique or not, because consistent can also be for a coincident line, so in which case it is an infinitely many solution. So we'll move to the next slide. Okay. Now we have understood how we could able to create a kind of a graph of a particular equation and solve it graphically to derive the solution for a set of the linear equation in two variable. So there is a method of algebra which can then also be used, and we have two methods, which is substitution method and we have an elimination method. So the substitution method, what we have to do, we have to solve the one equation in one variable, substitute it to the other equation, solve the remaining variable and substitute back to this. So basically what we have to do, if we have given a set of the equation, we have to convert that equation into one variable by either taking x to the LHS or y to the LHS and remaining equation to the RHS. And then once we have converted that particular equation into one variable, we have to use the value of that one variable in the second equation. And when we substitute that particular variable in the second equation, we'll get the answer for second variable. And then once we get the value of the second variable, we can substitute back into the first equation to get the value for the first variable as well. So we're going to discuss this in detail when we are going to discuss about the substitution method. Second method is the elimination method. What we have to do, we have to make the variable equal for one set of the variable, and then we can do the subtraction or the addition basis the equation that has been given, and then we solve that equation to create to find the value for the one of the variable, and then when we put that value of the one variable in any of the equation, we'll get the value for the other variable. And we are going to discuss all these in the detail with the solution with the example, so that both the methods are clear to you. So we will move to the next slide. Okay. Now we are going to talk about the example, not examples, in fact, the exercise 3.1, and we are going to discuss how we can solve the exercise 3.1. So we'll go question by question. So what question we have been given from the pair of the linear equation, the following problem. We have to first form the equation, and then after forming the equation, we have to solve them graphically. So we'll go with the first example then. So what is the first example? So first example is that 10 students of a class 10 took a part in the mathematics quiz. If the number of the girl is 4 more than the number of the boys, find the number of the boys and the girls who took part in the quiz. Okay, so we can form the two set of equations. So what we are doing, we are assuming the girls as x and the boys as y. The first is that we know that the total number of students are 10. So first equation is very simple because we know that total number of the girls plus boys is equal to 10. So first equation is x plus y is equal to 10. So this is the first equation. Second relationship is that we know that if the number of the girls is 4 more than the number of the boys, so which means that if we subtract the number of the boys from the number of the girls, we'll get 4 because number of the girls is 4 more than the number of the boys. So which means that girl minus boy is equal to 4. This is the second equation. So we'll solve this equation with the help of a graph. And what we are going to do, we are going to put the value for the x as 0 and get the value for the y. Likewise, we'll put the value of the y as 0 and get the value for the x. Similarly, in the second equation also, we'll put the value of the x as 0 and get the value for the y. We put the value of the y as 0 and get the value for the x. And when we plot both these equations in the form of the graph, we'll get the final answer, which is if you look at it, the answer is 7 and 3. So which means that this is a situation wherein L value of x is equal to 7 and the value of y is equal to 3. And what was x with this? X was the number of the girls and y was the number of the boys. So we have 7 girls and the 3 boys. We can validate the answers with when we put this value here. So 7 plus 3 gives us 10 and 7 minus 3 gives us 4. Which means that the answer that we have got is correct and it can be solutioned with the help of the graph in the following manner. So we'll move to the next question then. Okay, so second question is that 5 pencils and 7 pens together cost 50, whereas 7 pencil and 5 pens together cost 46. So find the cost of each. So this is also a simple one. So let's assume that the cost of one pencil is equal to x and then the cost of the one pen is equal to y. This is simple. And we know that 5 pen and 7 pencil cost 50 and 7 pens and 5 pencil cost 50, 46. So again, we are going to solve it graphically. So we are going to put some values. So as I mentioned, that easiest way is to put the value of 0 for the x and 0 for the y to get the corresponding value. But we can put any other value as well, depending upon the kind of the equation that we have. So in this, what we have done, we have put x as 3 and get the value of y as 10, and likewise we put y as 0 and get the value of x as 5. And in the second equation, we have put the value of x as 3 to get the value of y as 8, and we have put the value of y as minus 2 to get the value of x as 5. You can put any other set of the value to get the answer, but the moot point is there that you have to draw the graph very, very neatly so that you could able to derive the intersection point, which is this point. This is very, very critical. Because if we draw the graph haphazardly without using the proper scale, without using the proper ruler, then the answer, even though you got the intersection point, you cannot able to derive the answer. Because in that case, the answer will be wrong. So what we have to ensure that whenever we are creating the graphical representation of a set of the linear equations, we have to very, very clear in terms of the scale that we are using. So for the x scale as well and for the y scale as well, the difference between the two points should be equal. Then only we could able to get the correct answer, because our correct answer is not on the line, it is the point of the intersection, and point of intersection confirms that the particular set of the equation has a unique solution. So in this, we got the point of the intersection as 3 and the 5, and 3 and the 5 represents the value of the pencil and the value of the pen as well. So which means that we have the cost of one pencil as x and the cost of the one pen as y. So this is one pen, not pencil, rather this is pen. So we have cost of one pencil as 3 and the cost of one pen as 5. And this is the solution for this problem. We can validate this solution by putting the value back to the original equation so that we could able to confirm whether our solution is correct or not. So this is how we have to solve a particular set of the equation. But again, I'm repeating again that the scale has to be absolutely correct. When you draw the graph, it has to be a proper scale, using the proper scale and with the proper gap between both between the two set of points between the x-axis and y-axis, so that once you get the solution, the intersection point will give you the correct answer. Otherwise, you're not going to get the correct answer. So we'll move to the next question of exercise 3.1. Okay, So another set of question, which is the question 2, and in this question, what we have to do on comparing the ratio of A1 by A2, B1 by B2, and C1, C2, we have to find whether the lines representing the following pairs of linear equation intersect at a point or parallel or coincident. So we'll definitely do that. But before that, we have to make sure that our equation should be in the standard form. So in the first case, 5x minus 4y plus h, this is standard form. Again, this is the standard form. So we can simply apply the logic of A1 by A2, B1 by B2, and C1 by C2. And in the first equation, when we look at the A1 by A2, which is 5 by 7, and B1 by B2, which is 2 by 3, they are not equal. And hence, this particular equation has a consistent solution with one single solution or unique solution. And this is a consistent equation. In the second equation also, when we try to apply the same logic A1 by A2, B1 by B2, and C1 by C2, we find that all three of them are equal. Basically, these are a kind of situation wherein the lines are coincident and it has a multiple infinitely many solutions. And in the third equation, when we try to compare A1 by B2, B1 by B2, and C1 by C2, we find that A1 by A2 is equal to B1 by B2, but it is not equal to C1 by C2, which means that lines are parallel and it will not have any solution. So this is very simple way to make sure that we find this value. But again, the important concept and important thought or important point we need to remember is that the equation has to be in standard form. If it is not in the standard form, we have to convert in the standard form to apply the logic of A1 by A2, B1 by B2, and C1 by C. So we'll move to the next slide. Okay, so third question in the exercise 3.1 is that what we have to do on comparing the ratio, we have to find whether the pair of the linear equation are consistent or inconsistent. So again, we'll do the same logic here. We have to first apply the logic. In this case, the equations are not in the standard form. So we have to first convert the equation in the standard form. So what we have to do, 3x plus 2y minus 5 is equal to 0 and 2x minus 3y minus 7 is equal to 0. So once we have converted that equation into standard form, then we can again apply the logic A1 by A2, B1 by B2, and C by CV2. And the moment we find that A1 by A2 is not equal to the B1 by B2, then we confirm that this is a consistent and it has a unique solution. So if the first A1 by A2 is not equal to B1 by B2, then we need not to verify for C1 by C2, because A1 by A2 if not equal to B1 by B2 give us an answer that this is a unique solution with a consistent and unique solution. So I'll move to the next slide and see what are the answers for rest of the four questions. Okay, so second question in this is 2x minus 3y minus is equal to 8 and 4x minus 6y is equal to 9. We have to again convert the equation into standard form, apply the logic of A1 by A2, B1 by B2, C1 by C2, and C. So in this case, A1 by A2 is equal to B1 by B2 is not equal to the C1 by C2, which means that it is set of parallel line, inconsistent, and no solution. Then again also we have to do the next sector of the equation. So again to solve this equation, like first equation is set in the fraction, so we have to convert it into a by finding the LCM of 2 and 3, which is like 6, and then after applying that LCM we need to solve this equation, and this equation will then be converted into this equation itself. So basically we have applied the LCM and thus we have converted this equation into this form. And then we have set up the equation. So A1 is equal to 9, A2 is equal to 9, B1 is equal to minus 10, B2 is equal to B1 is equal to 10, B2 is equal to minus 10, and then we have C1 is equal to minus 42 and C2 is equal to minus 14. But in this case, we are just do application of the A1 by A2 and B1 by B2, and we've got that A1 by A2 is not equal to B1 by B2, and hence we conclude that this is a unique solution. In third equation as well, fourth equation as well, when we apply the logic, we find that A1 by A2 is equal to B1 by B2 or C1 by C2. So which means that this is inconsistent. It is consistent with infinite solution. And likewise for the last one, we apply the same logic and confirm that it is a consistent with infinite solution. So again, while doing this comparison, the first and most important point is to convert that equation into the standard form ax plus by plus c is equal to 0. If it is not in that form, then only we could able to apply the logic. Otherwise, our answers will be distorted. So we'll move to the next slide. Okay, the fourth question of exercise 3.1. What does it state that which of the following pairs linear equation are consistent or inconsistent, and if consistent, we have to obtain the solution graphically. So first one is x plus y is equal to 5, 2x plus 2y is equal to 10. When we solve it, we find that a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Therefore, lines are coincident and have infinitely many solutions. Hence, they are consistent. So what we'll do, we'll plot this graphically in this equation, and because these are coincident, therefore both the lines will coincide together to get the final answer. So we'll plot this graph and we find that the solution of both the equations is this, because all the points are coincident line are solutions in the given pair of the equation. In a coincident a coincident solution, all the points of both the line fall together. It's not like that we are going to have a unique solution, because it is the infinitely many solution, because lines are coincident. So we'll move to the next slide. Okay, so we'll come to the second question of the exercise 3.1, fourth out of fourth question. This is the second question of fourth one. So we have given a set of the equation, and when we apply the logic of a1 by a2 is equal to b1 by b2 is equal to c1 by c2, so we find that here a1 by a2 is equal to b1 by b2 but not equal to c1 by c2, and hence this is non-consistent. So we cannot draw a graph here because this is the parallel equation. And likewise for third question, when we try to apply the logic here, we find that a1 by a2 is not equal to b1 by b2. So which means that this can be presented on graph, and it is going to have a unique solution. So we'll again do some trial and error, but as I mentioned earlier as well, it's always better to take x as 0 and get the value of y, and y as a 0 and get the value of x. And likewise for second equation, I'll put the value of x as 0 and get the value of y, and put the value of y is equal to 0 to get the value of x. But again, I'm reiterating the same point that we have to draw the graph very meticulously. When we draw the graph, we need to ensure that the gapping between the x-axis and the y-axis, the points should be exactly used with the help of the scale. Then only we could able to derive the solution. So in this, the solution with that we have derived is 2 and 2, which is the unique solution for a particular pair of linear equation in two variables. This is very, very important. So we'll move to the next slide. Okay, so question fourth, sub question fourth of question 4 of exercise 3.1. So what we can see here is that we have set of equation, and when we get the value of a1 v2 b1 by b2 and c1 by c2, we find that a1 by a2 is equal to b1 by b2 but is not equal to c1 by c2. So which means that it is a inconsistent solution, and they are actually the parallel lines. Now we have a word problem here to solve in the form of the exercise 3.1. So for half of the perimeter of rectangular garden is whose length is 4 meter more than its width is 36. So we have to find the dimension. So what we'll do, we'll again take length as the x and width as the y. Step 2, we have to form the equation. So we know that length is 4 meter more than the width. So, and the condition 2 is that half perimeter is equal to 36. And we know that perimeter of a rectangle is twice of length plus breadth. So first equation is simple. We have given that the length is half of the length is 4 meter than the width. So which means that if we add 4 meter to the width, we'll get the length. So this is the first equation that we have found. We have added 4 to the width, which is equal to my length. And second equation is given to us that half perimeter is 36. So which means that we know that perimeter is equal to twice of x plus y. So if we remove twice here, we'll get x plus y is equal to 36. So this is the second equation, because half perimeter is equal to twice of x plus y divided by 2. So whatever value we get, that is equal to the perimeter, which is given is 36. Now we'll use the substitution method to solve this equation. So what we do, we know that x plus y is equal to 36, and what we have do, we can put the value of x as y plus 4 in the second equation. So that's what we do. So this is a substitution method, and we discussed about that in the slide, that what is substitution method. This is a clear demonstration that how we can use the substitution method. So in this equation, we have x is equal to y plus 4, and second equation we have x plus y is equal to 36. So what we have done, we have taken the value of x as y plus 4 and put that value into the second equation. So in x plus y is equal to 36, we are saying that x can be converted into y plus 4. So we can say that y plus 4 plus y itself is equal to 36. Y plus y is equal to 2y plus 4 is equal to 36. We take 4 to that side, and 2y is equal to 36 minus 4, which is 32, and then we'll divide the value with the 2 to get the value of y. So basically value of y is equal to 16. And once we have derived the value of 16, we put that value back in the first equation to get the value of x. So x is equal to 16 plus 4, which is 20. So this is like x is equal to 16 plus 4. This is a clear demonstration of a substitution method, that how we can use the substitution method to find the value for two variables in the pair of variable equation in two variables. So this actually explains the substitution method. So we'll move to the next slide. Okay, now we'll come to the question 6 of exercise 3.1, and what we have to do here is that we have given us a linear equation 2x plus 3y minus z is equal to 0. We have to write another linear equation in two variable that are geometrical representation so that their intersecting line parallels the coincident line. So given equation is 2x plus 3y is equal to minus 8. So for intersecting line, we know that a1 by a2 is not equal to b1 by b2. So we can create any equation wherein the x and y value of the a1 by a2 is not equal to b1 by b. That's a simple, like you can take any one. So I have taken in for the convenience x plus y minus 2 is equal to 0, because when we compare the value of x plus y minus 2 is equal to 0 with 2x plus 3y minus 8 is equal to 0, then in this case a1 by a2 is not equal to my b1 by b2. So typically we can use any equation, because if we have to form of consistent equation, then our a1 by a2 should not be equal to the b1 by b2. This is the prima facie condition, and we can take any equation to uh, which is having the intersecting line with the equation that has been given in the question. For second condition, parallel condition, we have to show that our C should not be equal. That means that our equation should be 2x plus 3y minus x plus 3y has to be there. Then we can take a value which is not in which C, in which my C is not equal. So when we solve it, in this case my C is not equal, and hence this is a equation which is equivalent to this equation. Not equivalent, which is the equation which is the equation which is being tallied with the first equation, and we have created an equation which is a parallel to the given equation. And then thus we have to create a coincident, so which means that all three has to be equal. So if our equation itself would be 2x plus 3y minus 8. So equivalent, that means that we can multiply it with any number. So what in this case what we have done, we have multiplied the original equation with 2. So 2x plus 6y minus 16 is equal to 0. Since this is equivalent, and when we convert the a1 by a2 to b1 by b2 and c1, all these are equal. So this is the equivalent of the original equation, but when we solve it, it is going to be a coincident lines and have infinitely many solutions. So this way we can create as many equations as we can use any other number. If we take 3, then this would be question becomes 6x plus 9y minus 24, which is again an equivalent equation. And if it is an equivalent equation, then definitely it is going to be have the infinitely many solutions. So we'll move to the next question. Okay, so now we come to the last question of exercise 3.1. So what we have to do, we have to draw the graph of equation x minus y plus 1 is equal to 0, and of 3x plus 2y minus 12 is equal to 0. Determine the coordinates of the vertices of the triangle form. So basically what we have to do, we have to first create a graph for both of them, and once we plotted the graph, we need to determine the intersection point. And we have, once we have determined the intersection point, we have to also determine the point where they are cutting the x-axis, and where we have triangular region basically. So it can be here as well, and it can be here as well. But what we have to do, what is triangle formed by? But we have to create a triangle which is from the x-axis, and hence we have taken this region. If this would have been y-axis, we could have taken this region. So what we have to do, we have to again solve this equation by putting some values to the x and the y's and get the value for the correspondingly y and the x. When we plot this graph, we'll get the intersection point. We have to extend that point to the x-axis to both the, and then once we have the point, we have to shade that region of a triangle. And if in the question it is being mentioned that shade the region with a triangle which is being formed with the x-axis, y-axis, then we have to shade this region. But in this case, we have to shade the region which is with the line and the x-axis. So this is the region which is 2 and 3 are the intersection point, and then minus 1 and 0 is the point here, which is line to the negative of the minus x-axis, and then positive is 4, 0. So these are the point minus 1, 0, 4, 0, and the 2, 3 are the point which are the points which is forming the triangle for these two set of the linear equation in two variables. So with this, we'll come to the end of exercise 3.1. Let's move to the next exercise, which is exercise 3.2. Okay, now we'll solve the problem for exercise 3.2. So what we have to do here is we have given a set of the linear equation, and then what we have to do, we have to solve this linear equation with the help of substitution method. So we'll start with the first one. So x plus y is equal to 14 and x minus y is equal to 4. what we have to do, we have to get the one variable at the LHS and rest of the information on the another. So in this, what we have done, we have kept x at the one LHS and then we have taken everything to the RHS. So in this case, what we are saying that x is equal to 14 minus y. Now what we have to do, we have to substitute this value into the second equation. So our second equation is x minus y is equal to 4. We'll put 14 minus y is equal to 4. When we solve this, we'll get the value of y is equal to 5. Now having got the value of 5 here, we'll substitute this value 5 in the first equation to get the value of x. So when we substitute value of 5 in this equation, we'll get x is equal to 14 minus 5, which is equal to 9. So we have the solution 9 and 5. Okay, now in second equation, s minus t is equal to 3 and s by 3 plus t by 2 is equal to 6. So again, we'll do the same logic. S is equal to 3 plus t. We'll substitute this value into the second equation, which is s by 3 plus t by 2 is equal to 6. We'll replace s with the t by 3. So we can see that t plus 3 by 3 plus t by 2 is equal to 6. We'll solve the equation by finding the LCM and then do the cross multiplication. And when we solve this equation, we get s is equal to 6. And when we'll solve this equation, we get t is equal to 6. Now, when we got t is equal to 6, we'll put this value into the first equation, which is the s is equal to t plus 3 to get the value of s. So with this, we get the value of s is equal to 9. So our values are s is 9 and t is 6. So we'll move to the next slide. Okay, now third question is 3x minus y is equal to 3 and 9x minus 3y is equal to 9. So when we look at the equation, we find that these are like coincident line, which means that a1 by a2 is equal to b1 by b2 is equal to c1 by c2. So which means that this is a kind of a situation wherein our values for a1 by a2, b1 by b2, c1, c2 are equal, and hence this is having the infinite solution. So we'll not solve this. So we'll move to the next question. 0.2x plus 0.3y is equal to 1.3, and then we have 0.4x plus 0.5y is equal to 2.3. So what we'll do, we'll first multiply the entire set of the equation with 10 so that we can remove the decimals from each of the equation. So equation is 2x plus 3y is equal to 13 and 4x plus 5y is equal to 23. Now, as a next step, what we'll do, we'll put everything on LHS as one variable and then take everything on the right side. So what we are doing in the first equation, we are putting x at the LHS and then we have taken everything on the RHS, which is 13 minus 3y and upon 2. Now we'll substitute this value x is equal to 13 minus 3y upon 2 into the second equation. When we'll solve this equation, we'll get y is equal to 3 and we'll put this value of 3 into the first equation, which is 13 minus 3y upon 2. We'll get the value of x is equal to 2. So the solution is x2 and y 3. Next equation, root 2x plus root 3y is equal to 0 and root 3x minus root 3y is equal to 0. So again, we'll follow the same logic. We'll keep the LHS as x and then we'll take everything to the RHS. So our x is equal to minus root 3 upon root 2y. We'll substitute this value into the second equation. So root 3 multiply by minus root 3 upon root 2y minus root 8y is equal to 0. We'll solve this. Root 3 into root 3 becomes 3 upon root 2 and then we have root 8y is equal to 0. We'll take y common here and then minus 3y root 2 minus root 8 is equal to 0. When we solve this equation, we'll get value of the y is equal to 0. And then will we put this value to 0 into the first equation, we get the value of x is equal to 0 as well. So in this case, we have both the value as 0. So we'll move to the next slide and see rest of the questions. Okay, coming to the next question then. So we have a question here wherein we have the values in the fraction. So for clarity, what we'll do, we'll first convert this fraction, we remove this fraction and convert the equation into a simple form by taking the LCM and doing the cross multiplication. So which we did for the both the equation, and then we have converted this equation without the fraction and cross multiplying, we have these two set of the equation. Now in this case, for simplicity purpose, we have taken second equation as the base and we have put the value of x is 13 minus 3y by 2 into the first equation. And upon solving this equation, we get the value of y is equal to 3. And when we put this value into the first equation, we get the value of x is equal to 2. Coming to the next question, 2x plus 3y is equal to 11, 2x minus 4y is equal to minus 24. We have to find the value of m, and where y is equal to mx plus 3. So for this, first we have to solve the value for the x and the y both. So for simplicity purpose, because 2x is common, what we'll do the subtraction of 1 minus 2. And when we do the subtraction of 1 minus 2, 2x will be removed and we only have the one variable, whereby 7y is equal to 35. We'll get the value of y as 5. When we substitute this value into the first equation, we'll get the value of x as minus 2. And we'll move to the next slide and see what value we get for the m. So we'll move to the next slide. Okay, so in this, what we are doing, we are putting the value of 5 is equal to mx plus 3. We have the value for x minus 2 and value of y is 3. When we put this value, we get the value of, sorry, we have y is 5. We have mx, which is like minus 2 and then 3. So 5, y is equal to mx plus 3, and then we have y as a 5 and x as a minus 2. When we solve this equation, we get the value of ms minus 1. Okay, now we'll try to solve the word problem here. So we'll go with the first one. The difference between the two number is given as 26, and one of the number is and one number is 3 times the other. Find the number. So we have two equation here. That difference between the two number is 26. So x minus y is equal to 26. This is given to us. And second, what we have given is that number is 3 times the other. So which means that x is equal to 3y. This is also given to us. So when we substitute that value in the first equation, so 3y minus y is equal to 26, we have the value of 2y is equal to 26 and y is equal to 13, and x is equal to 3 into 13, x is equal to 39. So numbers are 39 and 13. So we'll move to the next slide to see the solution for rest of the questions. Okay, so coming to the second question then, what we have given that there are two angles that are supplementary, and then one angle is larger than the other by 18 degrees. So first we'll put those conditions here. So we know that supplementary angle, sum of the angle is equal to 180. So this is the first equation, x plus y is equal to 180. And then we have given that one angle is greater than other angle by 18. So this is the second equation that we have got. Now in the first equation, what we can do, we can second equation, we have y is equal to x plus 18. We'll use this value, put it back into first equation. So our equation is x plus 18 plus is equal to 180. When we solve this, we'll get the value of x as 81, and then we'll substitute this value back into the first equation. We'll get the value of y is equal to 99. So our angles are 81 and 99. Now, next question, we have given that 7 bats and 6 balls cost 1300, and 3 bats and 5 balls cost 750. So we have taken bat as x and ball as y. We have formed two equation, and then again we have to do the substitution method. We'll solve this equation, and upon solving this equation, we get the value of bat as 500 and value of the ball as 50. And in the next question, we have given that there is a fixed charge plus variable charge per kilometer. So what we have taken, fixed charge as x and variable charge is y kilometer. And we have given that charge for the 10 kilometer is 105, charge for the 50 kilometer is 155. We have to find the charge for 25 kilometer. So we have these two set of equation, and upon solving them, we get the value of x as 5, and then we have value of y is equal to 10. When we put this value to get the value of the 25 kilometer, which is x plus 25. So 5 plus 250 becomes 255. So total cost for 25 kilometer is 255. Fixed cost is 5 per kilometer, and then variable cost is 10 per kilometer, which is dependent upon the distance. So we'll move to the next slide. Okay, now coming to the next question, which is the fraction problem. So we have given a fraction. So what we have to do, we have to denote the numerator with x and the denominator with y. So what we have been told that if we increase the numerator by 2 and denominator by 2, we'll get the fraction as 9 by 11. And if we increase the numerator by 3 and denominator by 3, we'll get the fraction as 5 by 6. So first we have to convert this equation by removing the fraction and doing the cross multiplication. So on solving the first equation, we get 11x minus 9y is equal to minus 4. And then solving the second equation, we get the equation 6x minus 5y is equal to minus 3. And then what we'll do, we'll solve this equation by substitution method and get the final answer for the x and y, and our fraction becomes 7 by 9. Next question, we have age problem. So we have a person who's Jacob, and then we have a son Y. So what we are saying, that Jacob is X and son is Y. So we have given that 5 year after 5 years the age of the Jacob is 3 times that of his son. So after 5 years, first what we have to do, we have to increase their current ages by 5 years, and then to adjust the equation, the age of Jacob is 3 times the son of the son. So we'll multiply the age of the son by 3 to get the age of the Jacob. And it's one factor, one equation also given that before 5 years. So before 5 years means that we have to reduce the current ages by 5. And before 5 years, the Jacob was 7 times the son of the son age. So we have to multiply the son age by 7 to get the value of the Jacob. So we have these two equations. First is equal to x is equal to 3y plus 10 and x is equal to 7y minus 30. When we solve this equation, we'll get the answer. Jacob has 40 years and son has 10 years. So we'll move to the next slide. Okay, now we are going to solve some of the examples here so that we have more clarity on few of the word problems. So example is that ratio of the income of two-person is 9:7. Ratio of the expenditure is equal to 4:3. If each of them save 2,000 per month, find their monthly income, and we have to use elimination method here. So we know that income minus expenses is equal to saving. So what we'll do, we'll create the two equation here. So let's the income be x and expenses is 7. So first equation we are saying that 9x minus what we are saying that the ratio of the expenditure is 4:3. If each of them said okay, then the equation will simply become we have to do the ratio of the income is 9:7, expenditure is 4:3. If we take income as x and the expenses as y, so 9x minus 4y is equal to 2,000 saving of first person, and 7x minus 3y is equal to 2,000 saving of second person. Now in elimination method, what we have to do, we have to make the coefficient of either of the equation equal. We can use the x variable or we can use the y variable. So in this case, we have used the y variable. So to make the y variable equal, we have to multiply the first equation by 3 and second equation by 4. When we multiply the first equation by 3, we'll get 9 into 3, 27x, 4 into 3, 12y, 2000 into 3, 6000. And when we'll multiply the second equation by second equation by 4, we'll get 7 4s are 28, 3 4s are 12, and 2000 into 4, 8000. Now in this case, our y can easily be subtracted because we have to subtract the first equation from second equation. So 27x minus 20, or let's say second from 1, you can do that. 28 minus 27 is equal to 1x, minus 12y plus 12y is reduced, and then 8,000 minus 6,000 is 2,000. So when we solve this equation, we get the value of y as we will get the value of x as 2,000. And when we put this value of 2,000 back into the any of the equation, we'll get the value of the y. So the solution of the equation is x is equal to 2000 and y is equal to 4,000. So what we have to do, we have to identify the monthly income and expenditure of a person. So for a person whose income was 9x, the income is 9 into 2, 18,000, and his expenses was 7x, 7 into 2, 14,000. And likewise for other person, it is 4 into income, which is sorry, this is the expenditure ratio. So 9 minus 4. So basically 9x is 9 into 2, 18,000, and 4 into 4, 16,000. When you minus 18,000 from 16,000, you'll get 2,000 as the saving. And likewise for 7 into 2, 14,000. When you multiply 3 with the 4,000, you have 12,000. So 14,000 minus 12,000 is again 2,000, which is the saving of that particular person. So we'll move to the next question. Okay, now another example that we are going to take is again for the elimination method. So use the elimination method to find all the possible solution of these two equations. So again, what we have to do, we have to do the balancing here. So we have first equation 2x plus 3y is equal to 8, and then we multiply this with the 2 just to make sure that it balances with the 4x. So we'll multiply the first equation by 2. So 2 into 4, 2 becomes 4x, and 3 into 2 becomes 6, and 8 into 2 becomes 16. But when we do this, our x and y is both cancelling out. So which means that this equation has no solution. So we cannot solve this equation. Next, we'll come to the example here. The sum of two-digit number and the number obtained by reversing the digit is 66. So, in the digit problem, what we have to do, we have to make sure that the digit is can always be represented in the form of the text 10x plus y because it is a two-digit number. So, let the tens place be x and the y place be 1 place be y. So, the first number may be written as 10x plus y, which is 10 into value of the x plus y. And when we solve it, for example, if 56 is there, so 10 into 550 plus 6 makes 56. So when digit is reversed, which means that x become the unit digit and the y becomes the 10 digit. So the number can be expressed as 10y plus x. So according to our equation, what is say sum of the two-digit number and the number obtained by reversing the digit is 66. So our number is 10x plus y, and we reverse the digits to 10y plus 6. So 10x plus y plus 10y plus 6 is equal to 66. This is the first equation. And second equation, we have been given that the number differ by 2. So which means that the difference between the two number is 2. Either x minus y can be 2 or y minus x can be 2. So we can use both the combination. So taking x minus y by 2 and when or y minus x by 2, when we put solve this equation taking either of the x minus y as 2 and y minus x as 2, we'll get the answers, and then we can use those answers to get the final digits, and digits can either be 42 or be 24. So we'll move to the next exercise then. Okay, now we're going to solve the exercise 3.3 with the elimination method here. So with the elimination method, solve the equation. So we have first equation as x plus 5 is equal to 5 and 2x minus 3y is equal to 4. So in the first equation, we'll apply the elimination method here. So what we'll do, we'll multiply the first equation by 2. So 2 into x plus 2y is equal to 10. Now our 2x minus 3y is the second equation. What we'll do subtraction of second from 1, and upon solving the equation we get the value of y as 6/5, and we put this value of 6/5 in the first equation, we get the answer as 19.5. Okay, we'll move to the next question then. Okay, so we have another set of the questions that we have to solve, and technique is largely the same. We have to balance the equation by equating the value of either of the variable of x or y in the first equation, and then we have to subtract the second equation from the first equation, or vice versa. You can do anything, and then upon solving the values, you can get the answers for all these questions. So the technique is simple. We have to do the same elimination method to solve all these questions. So we'll move to the next slide. Okay, now we'll concentrate on the word problem here, and see each of the word problem is unique here. So we have first problem of the fraction, second problem of the age, third problem of the digit, fourth problem of the money, and then we have fifth problem of fixed charges and the variable charges. So these are largely the five different set of the problem that normally comes. We'll try to solve all this problem one by one in the next. Okay, so first is the fraction problem. So what we have given is that there is a fraction, and then we denoted the fraction with the form of x and y, where numerator is equal to x and denominator is equal to y. And then what we have been given, if we increase the numerator by 1 and decrease the denominator by 1, our fraction become 1. And if we only increase the denominator by 1, our fraction become 1 by 2. So these are two set of the equation. We have to first solve the equation by removing the fractions and cross multiplication. And then once we have obtained the final equation, we'll solve those equations with the elimination method to get the final number of x and y. And then we have a fraction 3/5. Next, we have an age question, which is like same of the question of the Jacob and his son. So we have Nuri and Sonu here. So age of the Nuri is X and age of Sonu taken as Y. And then again the same condition. Before 5 years, the age of Nuri is 3 times the age of Sonu. So we have to multiply the age of Sonu with 3 to get the age of the Nuri. Likewise, after 10 years, the age of the Nuri is twice the age of the Sonu. So again, we have to apply the same logic here to get the final equation. So upon solving this final equation, we get the final age of Nuri and Sonu. Now we'll come to the another question of the digits here. So again, we have to assume the digit as 10 as x and the unit as y, and our original number is 10x plus y. So we have given that sum of the two-digit number is 9. So x plus y is equal to 9. This is the first equation. And in second equation, what we have given is that the 9 time of a particular digit is equal to twice if we reverse the number of that particular digit. So we have original digit at 10x plus y, and after reversal we have 10y plus x. So 9 times the original digit is equal to twice after reversing the digits there. So we have the two set of the equation. Again, we have to do the elimination method to solve this equation, and then we have two digits, which is x and y, and then we can use this x and y in the original equation, we'll get the number. So we'll move to the next slide. Okay, now we have another question on the which is on the notes. So we have given that notes of 50 and 100. So we are saying that let the 50 rupees note is equal to x and 100 rupees note is equal to y. So there are two things here, the volume and as well as the value. Wherever we are using the volume, then we have to simply use x and y. But the moment we are using the values, then we have to use 50x and 100y because value is denominated with the value of the note. So we have given that sum of the note is x and y. So this is the quantity of the notes. So x plus y equal to 25. But what we have given the value of the currency is 2000. So we are saying that 50x plus 100y is equal to 2000. So wherever value is there, we have to use the 50x and 100y because value is represented by the denomination of the notes. But wherever we have given the quantity, we have to simply use the quantity because this is the number of the notes. So again, when we solve this equation, we get the value as well as the volume. So we have the value as volume as x is equal to 25, which means that we have 25 notes of so x is equal to 10, and we have y is equal to 15. So we have 10 notes of 550 and 15 notes of 100, and then we add it, we get the value as 2000. Last question is on the fixed charge and the variable charge. So let the fixed charge be x per day, and then we have the extra charge of y. Now we have given that fixed charge is there for first 3 days. So which means that for extra charge, it has to be only the number of the days post 3 days for which extra charge would be charged. So if somebody is using library book for 7 days, then extra charge would only be for 4 days because fixed charge will apply for the 3 days. And likewise, if somebody is using the lab book for 5 days, then extra charge will apply only for 2 days. So our first equation is that fixed charge plus extra charge of 4 days is equal to 27, and fixed charge plus extra charge of 2 days is equal to 21. When we solve this both equation, we get the value of the fixed charge as well as the per day charge. So with this, largely we come to the end of this chapter. Now we'll quickly go to the next slide and look at some of the key points that we need to remember as a part of this chapter. Okay, so key points that we need to remember as a part of this chapter is that a pair of linear equation in two variable can be represented and solved by the graphical method and algebraic method. And within the algebraic method, we understood that there are two methods, which is substitution and elimination method. So graphical method is the graph of the pair of the linear equation in two variable. If the lines intersect at a point, then definitely it has a unique solution. And if the lines coincide, there are infinitely many solutions. And if lines are parallel, then there is a no solution. Algebraic method is having two methods, substitution method and elimination method. And if the pair of lines are given, then standard form is a1x plus b1y plus c1 is equal to 0, and a2x plus b2y plus c2 is equal to 0. And if a1 upon a2 is not equal to b1 by b2, that's a unique solution. If a1 by a2 is equal to b1 by b2 is not equal to c1 by c2, then we have a situation which is an inconsistent situation, and this is a line graphically it's a parallel lines. And then we have a1 by a2 is equal to b1 by b2, c1 by c2. These are coincident line. So solution is overlapping solution, and it is infinitely many solution. And then there are several situations which can be mathematically represented by two equations that are not linear to start, but we alter them so that they are reduced to pair of the linear equations. So with this, we'll come to the end of the chapter. Let's move to the final slide and see what we have as a part of the next chapter.